everybody. I am ERCAN KIZILAY, working for ERCAN KIZILAY Transportation Technologies and studying Master of Science of Electrical Engineering in Yıldız Technical University, Istanbul. Today, I am going to present mine and my co-author, Sibel Zoğlu-Partas studies about controlling and condition monitoring of railway point machines. Railway points, as you can see in a basic railway point, are defined as pair of tongue rails with their stop rails. Main control mechanism in the figure is number 1, point machine, and number 2, blades. Switching the points, locking the points, and supervising the point implemented by point machines. In figure, you can see Bombardier Abbey Point 500 electromechanical point machine and its parts. While developing railway signaling equipment, you have to respect EN 50126 RAMS demonstration standard and D series. You can see the relationship between these parameters. The EN 50126 also provides a life cycle model, should be followed. Standard gives the steps of development in the first branch. First, you have to start with your system concept, afterwards definition of the system, and its operational context should be completed. In third step, you must take a risk analysis. As a result of risk analysis, countermeasures, threats, etc. should be the input of the specification of system requirements. Following steps should be defining the architecture of the system, then you design your system and manufacture accordingly. At this point, your product is ready to be certified. In this study, purpose and concept is to integrate the safety and non-safety system in the control circuit. Purpose is switch and supervise the point with 4-wire with a control circuit, which is 1 out of 2 architecture. For condition monitoring, the purpose is using the current and voltage sensors integrated to control circuit. Collected current and voltage data and additional diagnostic info should be evaluated in regular MCUs. Requirement analysis is a cornerstone for a safety critical process. To make it complete and consistent requirement set, first, you have to analyze technical, functional specifications and equipment specs. You could also have some constraints from contract and special terms. Then you must create a software and hardware requirement specification. In order to make a traceability, layer 1 and layer 2 should be linked. Finally, you have to write verification requirements in order to finish requirement process. This part also requires traceability in between. In the system architecture, first analyze functionality according to requirements. Analysis method in this figure is EFFBT, which means Enhanced Functional Flow Block Diagram. Second, allocate requirements to physical architecture. That you must draw your physical architecture, comply with your requirements and your functionality. Third, you have to define configuration items and allocate functionality to physical items. You can see the allocation. Each function has a part in the physical item. Then you should describe your interfaces and design the components as configuration items. In details, function 2 is broken down more detailed level. Function 2.4 is about position reading and it is initial function of the controller. Function 2.1 is switch over signal power operation, which select the which cable function needed. Function 2.3, 2 and 2.3 are the motor driver functions. Since the hybrid contact technology to be used for safety reasons, sequence shown in figure should be implemented in the software. Therefore, states and modes of the controller should be defined. After allocating the functions of the software block, you have to create algorithm with ANSYS or model-based any other program. Algorithm should be tested and model coverage should be calculated as 100%. Condition monitoring software should have the functionality with the following: temperature monitoring, safety MCU diagnostic collection, phase sequence monitoring, voltage monitoring, component failure monitoring, current measurement, which I have done with the experimental board, and FFT of the measured current, which I have calculated. According to EN 50126, safety analysis should be conducted both inductive and deductive approach. For the inductive approach, you have to make a failure modes and effects analysis. In the table, you can see the architecture parts of the system or the controller. Every function block and functions has been put in here. Failure modes and evaluated failure modes and effects and countermeasures can be seen in the table. As deductive method, you can see the FTA, fault tree analysis. In the fault tree analysis, overall controller fault can be seen in the left picture. and the wrong position reading fault can be seen in the right picture. In the right picture, you can see that common cause failure in between the components has been calculated. As I discussed, digital technologies in railway are increasing day by day. Railway points should work safely and reliably for the maneuvering movements of the trains, and their availability should be high. In recent years, the use of digital railway signaling system has become very common in many countries. In the technologies examined during the research, the safe control of point machine is used in many applications. While designing the safety critical system, it must be fully traceable due to its functional distribution and interconnection between activities. The determined approach must be systematically operated with the methods specified in the CLX standard. For a C4 system design, process should be approached in a systematic way according to its requirements, safety analysis, architecture, and design. In this study, the integration of preventative maintenance operations with point machine control circuits has been investigated according to the requirements of EN 50126 standard and the steps of V model. During the research, the control circuit requirements were analyzed with IBM doors, and the model-based design and algorithm were made with ANSYS SCADE. These two programs have been integrated with each other for traceability purposes. The maintenance research done in the study shows that basic integrity between safe and unsafe MCUs can be achieved. This data processing can be used for preventive maintenance and allows the operator to start maintenance work before the system shuts down. In continuation of this work, the production of completed system and the completed solution may be future studies. Thank you for your listening.
Yeah, it's a good presentation.
Thank you.
I don't think so any questions. Your presentation is really good, simple, and in time you are presented. I don't think so any questions will be there from this one. So we'll Mustaq will go to the next presenter.
Thank you.
Thank you very much, sir, for your very good presentation. And as we can see that no one